of RDSO. They will cover the entire railway, and we will be able to know where is the how much clean cushion, and accordingly deep screening action can be taken. This also work has already been sanctioned and tenders are being invited by RDSO. Lot has been told by number of speakers about track geometry, measurement and feed to the machines. We are procuring all the machines having ALC and DRP system. These parameters can be taken from these trolley and fed to the machine for better output and faster working. Two agencies are already working, Emberg and EMIL. Northern Railway Construction, DFC, they are using extensively, and other railway can also start using these trolleys to have a better quality output. Our track will be fit for what we are telling 160 and 200 kmph. Once we tempt with these data collected with these trolley and with machine, then there will not be any problem. We have sanctioned rail grinding machine to cover entire Indian railways. In addition to rail grinding machines, some rail milling machines are also proposed for rail repair. Already told data, now we can record all the data under load after tamping. Axle box acceleration can be measured to know the track defect. Earlier we were measuring only on 50 number of such we are going to provide. With all these things, or whatever is less than 10 GMT sections, we are going to start Konkan Railway type of maintenance. For that, procurement of machine is on the way. But in the meantime, we can use UTVs available with us and pickup vans to start at least 2 ANs by April in each zonal railways.
The last two slides. About 65 bridges have been commissioned with automatic bridge water level monitoring system, which are sending data to our system and as well as SMS in the morning. And these are intelligent field devices. That means if the water level is touching around danger level, then SMS frequency increases and things are linked. Those intelligence are built in the system. Now this has to expand to almost 600 bridges which have been identified. Similarly, continuous rail thermometer, CRT, has also been made intelligent to send requisite device when the patrolling should be introduced depending upon temperature and de-stressing temperature of that area, particular area. This is also to be commissioned on identified locations. Thank you so much.
Thank you, Mr. Awasthi and Mr. Khandelwal for a very comprehensive presentation on the roadmap of Indian Railways Engineering Department as far as IT and track machines are concerned. Now with this presentation we come to end of the presentations. A lot of questions have been raised by the audience, but considering paucity of time, I request all the presenters to pick up one question and answer, whichever one they feel like.
There is one question from ED Track 1 RDSO, sir. Whether the acoustic wireless sensor network system has been implemented on any operational railway? No, sir, it has not been implemented on any operational railway. Rather, the opposite of this technology, where instead of sensing the acoustic waves, the waves were implanted into the rails and they were sensed on the distant sensors. This was tried in UK, but due to certain limitations like this, that was not a continuous system and that cannot monitor the fracture when the track was occupied with the running trains. Operationally, that system was also not implemented. But acoustic wireless sensor network overcomes all those limitations, but still it has to be implemented on any operational rail. Thanks.
Most of the questions for working of trolley are raised with respect to the maintenance. But as in our project, that is Kanpur to Khurja, we are basically using for a construction project where many of the locations we have even erected the electrical mast and other essential installation much before the track laying. So we definitely need an absolute track profile which we have designed. So there is a necessity to provide the track at the absolute profile. And one of the questions, there was some reference that what are the effects of curvature correction of earth. So since we are working in the tolerances of about a centimeter, so that does not make any, appreciable difference. And since after completing the round of measurement, we are analyzing the results. We are also putting the obligatory points, and we are also limiting the slows and lifts. So as before fitting into the machines, we have two type of machine. One is of Placer, one is of Hasco. So it is compatible. The output can be given, the input can be given to both the machines. The output is derived from the Trimble trolley. So in both the trolleys, the system is working and the obligatory points are taken care of. And definitely the corrections sometimes is not done in the one round, it is also done in the subsequent round. So with that, we are maintaining the absolute profile. And I invite every one of us, anybody can come and see, because not only the mechanized laying of track machine, which is at the first instance we are maintaining the accuracy of to the absolute profile to the extent of 5 centimeter. Then by correcting by Trimble trolley, we are maintaining to 1 centimeter. So the absolute profile is definitely maintained. Thank you.
Sir, I have received many questions. Before I take up any question, I'll just try to sum up. Actually, in this proposed concept which I have submitted, in this attenuation, that is the wave propagation, whenever it is moving in any material, there is definitely loss of energy. Now, if you have a rail which is having only design discontinuities like fish-plated track, SCJs, points and crossings, etc., then what happens is that the intensity of the vibration or the signal is known. We determine it by increasing it. So when we say that we have a stepping motors, nowadays stepping motors are available, so you can alter the intensity of the input signal. So that signal, and then the signal which is detected at some distance apart, that is known. So we have a comparison between the detected signal and the input signal. Now whenever there is an unwanted discontinuity like a rail fracture, then there is a major loss of energy. Now because of this loss of energy, the output signal or the signal which is being sensed, there is substantial drop in it. That we compare and then come to a conclusion that there is a rail fracture. So that so some questions that what attenuation is, whether there is attenuation or not, or discontinuity track, can it be detected? So main thing is that there has to be a physical separation, then only there will be a substantial loss of energy and our accuracy will be better. And what if we try to detect only the cracks, then probably there will be a lot of alarms, false alarms. Now the detection, this will depend upon the distance. That is, we can have blocks of 250 meters. So within 250 meters, we can isolate and then identify exact location of the cracks. Thank you, sir.
Question from one Mr. Majumdar, SSC PV. I'll request him to meet me during the break after this session. I'll explain to him about the diamond crossing, how it is to be entered. Then question from XGM HK Jaggi Saab se hai. Just to answer the question that in these applications where it is BFT, private siding approvals, or in case of NHI related GAD approval system, identified people have been given a user ID and password also for that purpose. And if there is an interface of CST, CEG, CTPM or CPTM, for them also user ID and password has been created. They have been made part of the system. Thanks.
is a question from Mr. Acharya, IPWE Bilaspur. He says that we are not aware about what is machine. Whatever machine operator says, he packs and goes away. So it depends on us how much we want to know. When machine comes to your section, if you go on the machine and try to learn, that is first stage where you can start learning. In addition to that, for a systematic learning, from last year we have started regular courses for all, not only track machine operators, PWIs and APWIs also at IRTMTC, Allahabad. So courses are conducted regularly. Zonal Railways should nominate PV supervisors for getting training in those courses. That purpose of starting those courses was same for such feedback. But for PWI to learn, he has to work with the machine. He will automatically learn about all the items.
There are many questions from tunneling. The one question is, how much is the time needed for 1 kilometer tunneling? It's a very general because it depends upon where the tunnel is being constructed. If the tunnel is being constructed in the new line, naturally there is no constraints, very less constraints there. And if you are constructing the tunnel parallel to your double line, naturally there are big constraints. So everything is depend upon the drill and blast method, and that depends upon the control blasting, because you are reducing the quantum of amplitude by breaking the blasting in number of sequences. So naturally peak particle velocity is reduced, and as per your existing structures character and rock mass, the pull to the tunnel is to be decided. If everything is okay, then 2 meter pull can be taken very easily, and if you multiply it with the faces, both the faces is 4 meter per day. 4 meter per day means in a year you can complete 1 kilometer of tunnel by drill and blast method, similar to the NATM technology. But before that you have to reach the portal area first, because to reach the portal you have to cut the mountain, and you have to ensure that the above the tunnel portal there must be a 2D distance, means size of the tunnel it should be multiplied. If its tunnel size is 7 meter, 7.5 meter, so minimum 15 meter head is required, otherwise your tunnel will collapse there. So that is the requirement. And one very important question, Mr. SSC Imphal, I think he is facing, he is saying that there is a squeezing or lifting of the tunnel base actually, and some crown displacement is also there, and vertical walls displacement is there. I already have told that it requires a horseshoe type of tunneling now. D-shaped tunnel is now almost bent. You have to avoid the D-shaped tunneling. It is just like आप जो भी major bridge बनाते हो, you give a camber. It is just like in the side wall, you are giving a camber, means you are giving just like this shape, and you have to complete close the tunnel, means you have to ring close. Very simple concept. A ring you cannot compress it. So there is ring closure system should be there. A egg cannot be broken like this. So first of all, suppose you are facing this problem, so the only solution is you have to connect your unstable portion of the rock mass to the stable portion by rock bolt only. So put some rock bolts at a very closer interval and see its performance, and accordingly you can decide what should be the depth of the rock bolt. Nowadays the rock bolt having a depth of around 5 to 6 meter, or even cable bolts are available, so you can transfer the unstable portion of the rock mass to the stable portion zone. A reef or any sorts of temporary support cannot support the dead mass, and it will collapse with a very sudden collapse methodology. So the rock mass and the short skating is the only methodology. Thank you.
There are two questions from Shri P.K. Garg, CETMC, Central Railway. Sir, we have GPR technology up to a speed of 130 kmph, and we are going to mount this GPR system on existing 2 track recording cars. Second question is, what is the wavelength and type of defects we are aiming to detect using Excel box accelerometers? Up to a speed of 130 kmph, the track defects in a range of 3 to 25 meter wavelength are rational. And above 160 kmph, this should be in the range of 25 meter to 70 meter. In the Excel box measurement system, we are aiming to establish a correlation for the speed of 160 kmph. The all track defects in a range of 3 to 25 meter will be correlated with the accelerations at different speeds.
The question is from Mr. Ganpati. The video capture data, how linked to field identification of track components. In the system, the video recording and inspection of the track is synced. So it is synced together and it's stamped together. It is being stamped regularly. So whenever there is a defect, you can easily correlate with the video frame of that particular moment, and you can correlate with the track feature which is causing that defect or the defect arising at that particular feature. Thank you.
Three questions from Mr. MP Singh, DBS, CBI, RDSO. First is, can't IS codes available for hydropower tunnels be followed? Secondly, when a strata is able to stand on its own while blasting, then why can't properly designed lining ensure safety? Why separate tubing must? Third is, instead of one safety tunnel, why not go for 2 separate tunnels for up and down traffic? I will discuss, I think, all the questions in short. Okay. IS codes we can use, but here we are using NATM method. In IS code, some empirical formulas are there, but NATM is more elaborate, where we are considering lots of details, soil details, ingress of water. Based on that, we are designing. So if we use IS codes, we cannot use the maximum utilization of NATM, which is more economical also. Thank you.
There is only one question, that is from PC NFA. Why should not trainees are given training on sample running track than simulator? It's possible to train them on a real track in a block. Sir, actually in simulator, this is a sample track of 200 meter, and the major advantage is that they can break as many sleepers as they want to learn, and in block they cannot break even 2 or 3 sleepers, otherwise from the next time block will not be given. Thank you.
There is one question from Mr. P. Sharkar, SSC Senior Section Engineer, Construction, MLG, Drawing. In calculation and the analysis, formation is not taken into consideration, but I think formation weakness has also considered to ballast resistance. Say ballast penetration is a phenomenon which is related to the track weak formation. My answer is parametric studies had been carried out for the 90% reduction in stiffness. In my case, in my presentation, case 4, mostly the 90% reduction in the stiffness beneath the rail seat. It is almost similar condition simulating the ballast puncturing up to the 1 meter due to the weak formation. And it is the most severe condition causing the 60% reduction in the natural frequency. Thank you.
In the end, I like to mention that there is a small request query from the audience name is not mentioned. This is addressed to the IPWE. It reads like the PowerPoint of all sessions are keeping in recent IPWE website. Is it so? And since same that is the PPTs are very useful for future, please clarify. So I'll request IPW to take action on this. With this, we come to end of this session. I sincerely apologize all the speakers for restricting them and controlling the time. Still, we failed in controlling the time. Thank you very much.
Thank you, Chairman Sir and Co-Chairman Sir, and also all the authors, all the presenters present here, and the patient audience too. And in fact, Pragya, I believe they're a great audience, listening to everything, putting up questions on everything and getting the answers out of it. So since this session is over right now I'd like to request Shri B.S. Banga. I'd request Shri B.S. Banga after some time, of course, but right now I'd like to request the chairman of this session, Shri S.N. Agarwal, the General Manager of South Eastern Railway, and the co-chairman, Shri A.K. Sachan, the Chief Administrative Officer, Construction, Udhampur, Srinagar, Baramulla Rail Link Project of Northern Railway, to kindly present the mementos to the authors of this session.
May I call upon Shri Anish Kumar, Director, Station Development and Railway Board Engineering, to please take collect the memento. Thank you, sir. The second paper was presented by Shri Atul B. Khare and Shri Manjan Mathur. Atul B. Khare, sir, is a Chief Project Manager, Tunda, Dedicated Freight Corridor, and Shri Manjan Mathur is Group General Manager, Eastern Corridor, Dedicated Freight Corridor. Thank you, sir. The third paper was co-authored by Shri Parth Mittal, student BTech, IIT Delhi, and Shri A.V. Mittal, Deputy Chief Engineer, Northern Railway. Thank you, sir. The next paper was authored by Shri A.K. Roy, Chief Project Manager, Rail Vikas Nigam Limited, and Shri Rajesh Prasad, Executive Director, Rail Vikas Nigam Limited. Thank you, sir. The next paper was co-authored by Shri R.P. Tiwari, Director, Track Machine, Research Design and Standards Organization, and Shri Rahul Singh, Joint Director, Track Machine, RDSO. Thank you, sir. The eighth paper for the session was written by Shri Anil Kumar, Chief Engineer 5, Construction, Northeast Frontier Railway, and Shri Yogesh Verma, Deputy Chief Engineer, Construction, Northeast Frontier Railway. Thank you, sir. The next paper for the session was written by Shri R.K. Agarwal, Chief Engineer, Track Machines, North Central Railway, Shri Satya Prakash Mishra, Principal, Indian Railway Track Machine Training Center, and Shri Bhavesh Kumar Bharadwaj, Chief Instructor, Indian Railway Track Machine Training Center. The next paper was presented and written by Shri Sandeep Kumar Saha, Divisional Engineer, Ranchi. Thank you, sir. And the last paper was written by Shri B.P. Awasthi, Executive Director, Track Procurement, and Shri A.K. Khandelwal, Executive Director, Track Machine, Railway Board.